Good day, students. I am Sir Rolly. Welcome to week 3 of the third quarter of Mathematics 9. Based on pivot bow, our learning tasks are the following. Number 1, prove the midline theorem. And number 2, prove theorems on trapezoid and kites. For this week's task, you will focus on other forms of quadrilaterals. You will define trapezoid, isosceles trapezoid in particular, and kite. You will also prove theorems applied to them as well as the midline theorem. Let's recall our lesson last week. We proved theorems on different kinds of parallelograms, particularly rectangle, rhombus, and square. Our output was such an enjoyable one because we used the singing talent of the students to prove their theorems. For this week, let's start with the midline theorem. The midline theorem states that the segment that joins the midpoints of two sides of a triangle is parallel to the third side and half as long. This leads to the mid-segment theorem of trapezoid, which states that the median of a trapezoid is parallel to its base and its length is 1/2 the sum of the lengths of the bases. Let us now discuss the properties of isosceles trapezoid. The base angles of an isosceles trapezoid are congruent. Opposite angles of an isosceles trapezoid are supplementary. Diagonals of an isosceles trapezoid are congruent. On the other hand, here are the theorems of a kite. Theorem 1, the diagonals of a kite are perpendicular to each other. Theorem 2, the area of a kite is half the product of the lengths of its diagonal. For learning tasks 1, 2, 3, and the assimilation part, let's deepen and widen your knowledge to fill in the missing statements and make reasons to complete the 2-column proof. Make sure to answer the assessment part as well, and write your personal insights of the lesson in the reflection part. What are your plans for this weekend? Have you ever flown a kite? Watch how this student construct a lofty kite with the use of the theorems that he learned for this week.
Annyeonghaseyo! Do you want to know how our family spends weekends? If so, please watch this. One Saturday, me and my family decided to make a kite. We started to plan on how it would look like, and here it is. For this to become lofty, we must make sure to take into consideration the theorems of a kite. Theorem 1. In a kite, the perpendicular bisector of at least one is the other diagonal. To show this, come and join me as I measure the lengths of the diagonals, and let's see if one is the perpendicular bisector of the other. The first diagonal measures 32 centimeters. The other diagonal measures 55 centimeters. But wait! How can I prove if the first diagonal is the perpendicular bisector of the second diagonal? Yes, you're right. I will use a protractor. I got it! They form 4 right angles. And let me measure these 2 segments. They are of the same length, which is 16 centimeters. Therefore, we can conclude that the second diagonal is the perpendicular bisector of the first diagonal. And now that we know the measurements of the diagonals, we will now be able to find its area. According to Theorem 2, the area of a kite is equal to half the product of the length of its diagonals. Come on, let's show them the area of this kite. This kite is 880 centimeters squared. Come on, let's do the kite! Voila! Here's our kite! Join our family as we show how lofty this kite is. Try it with yours. Good day, everyone.
This is Pivot TV, your quick guide to learning. See you again next week. Happy learning!